Hey guys, today we're going to talk about sections 2A and 2B in your book, which are conversions. And conversions are very important in the real world. I don't know if y'all know of one of the catastrophes that NASA had when one of their space shuttles blew up, but it was because people were not converting properly between the metric system and the US system of measurement. So it's very, very important that we know how to track units and convert from one into the other. So at the end of your lab book, there are a bunch of conversion facts, and we do not expect you to have these memorized by any means. On the test or on a quiz, we will either let you use the back of your book, the back of your lab book, so you can look them up, or we will give them to you. So please do not fret and feel like you need to memorize them. You don't. We will make sure you've got what you need. Also, sometimes they're written two different ways. In this example, we have $1 is 0.7875 euros, and $1.2699 is equal to 1 euro. These may look different, but they're actually the same. If you take that first expression and divide both sides by 0.7875, 1 divided by 0.7875 is equal to the 1.2699, and then 0.7875 divided by 0.7875 is 1. So you can see that you can convert from one to the other by doing some simple division. So you can use either facts as long as it connects the two things that you're looking for. So for example, let's say that you wanted to, or you know that your mass is 65 kilograms and you want to know how many grams that is. Well, a conversion fact is that 1 kilogram is made up of 1,000 grams. So we would start with the 65 kilograms. Always start with what you know. You know that your mass is 65 kilograms. And we see that we have that on the top part of a fraction. You see you have kilograms up top. Well, with a fraction, the idea is to cancel units. If you have something on the top and the bottom of a fraction, they cancel. So we're going to take that conversion fact and we're going to arrange it so the kilogram part is on the bottom. And that way, if we look at our fractions, we see a kilogram on top and a kilogram on the bottom. Those are going to cancel. So we start with what we know, the 65 kilograms, and we're going to multiply it by 1,000 grams over 1 kilogram, so the kilograms cancel, and now we're in grams, which is the units that we want, and we can just do the basic multiplication. On top we have 65 times 1,000, on the bottom it's just 1 times 1, so 65 times 1,000, we're left with grams because those kilograms canceled out, give us 65,000 grams. So the whole idea with these unit conversions is to track your units. Let's look at another one. Let's say that you know it's 45 miles from Raleigh to Sanford, and you want to know how many kilometers that is. Well, 1 mile is 1.6093 kilometers. So again, start with what we know. We know that we have 45 miles, and because we have miles on the top of the fraction, I didn't write the over 1 in this one because you don't have to, but if it helps you, you can definitely put that number over 1. But since miles are on top, we need miles on the bottom. So we write it as 1.6093 kilometers over 1 mile. Again, the miles cancel, and then we just do the multiplication. The 45 times the 1.6093 kilometers gives us that the distance from Raleigh to Sanford is 72.42 kilometers. In our next example, we know that a football field is 100 yards long, and we want to know how many inches this is. Well, in the back of your book, it doesn't convert from yards to inches, but we do know that 1 yard is 3 feet, and 1 foot is 12 inches. So this is an example of a compound conversion where we're doing a couple different things at once. So again, start with what we know. We know that the football field is 1,000 yards, or 100 yards. Then we can get rid of the yards by putting 3 feet over 1 yard, so we have a yard on top, yard on bottom, they cancel. And then we're going to multiply that times 12 inches over 1 foot. Because we had a foot on top, we need a foot on bottom so that those units cancel. So we've canceled out the yards, canceled out the feet. Now we're left in inches, which is what we want. And then we just multiply across the top and multiply across the bottom to see that 100 yards is 3,600 inches. A couple more examples. These are getting a little bit more fun. Let's say we want to convert 60 miles per hour to inches per minute. The goal is to keep track of those units. Focus on canceling them out. If we're trying to get miles to inches, these are both measures of distance. We know that 1 mile is 5,280 feet, and we also know that 1 foot is 12 inches. So we can go from miles to feet, then feet to inches. That gets us from miles to inches. Then we also have our units of time, which are hours and minutes, and that one's a little bit more straightforward. We know that 1 hour is 60 minutes. So again, start with what we know. We have 60 miles per hour, and if you read through the 2A and 2B PowerPoint, you see that that word per means divide. So So we're going to write that as 60 miles per hour as 60 miles divided by 1 hour to start off our fraction chain. So we have miles on top, hours on bottom. And let's start by getting rid of the hours. So in our next one, we know that 1 hour is 60 minutes. We're going to put hours on top so the hours cancel, leaving us with minutes. So we got rid of our hours, we turned it into minutes. Now we need to go from miles to inches. So we have a miles on top, we need to put miles on the bottom. So we'll put 5,280 feet over 1 mile to cancel out the miles. And now we're in feet, we're trying to get to inches, so we need to write 12 inches over 1 foot to cancel out the feet, leaving us in inches. So we got rid of the hours, we got rid of the miles, got rid of the feet, so now we're left in inches per minute, and then you just multiply across the top, and then multiply across the bottom to get our final answer in inches per minute. Let's say that now we want to carpet a room, and our room is 10 feet by 12 feet, and if you multiply those two, just basic area, we have a total area of 120 square feet. But carpet is sold by the square yard. So this is a really real-life application. If you go to Home Depot or Lowe's, sometimes you've got to convert from what you have into how they're selling it. You don't want to buy too much or too little for your project. So we want to know how many square yards of carpet do we need. So we're starting with what we know, the 120 square feet. And we know that 1 yard is 3 feet. But if you notice, we have feet squared in our 120, but 1 yard is only 3 feet. The unit is singular, it's not squared. So what we have to do is we have to square the whole thing. We put 1 yard over 3 feet and we're going to square that whole fraction. So 1 squared is 1 to get the 1 yard squared up top, and then 3 squared is 9 to get 9 feet squared on the bottom. And now our units match. We have foot squared on top and foot squared on the bottom. They cancel. So if we do 120 divided by 9, we see that you need to buy 13.3 yards squared of carpet. So the key is keeping track of those units. You want to get the units to cancel. One more example like this. Let's say that a new sidewalk will be 4 feet wide, 200 feet long, and filled to a depth of 6 inches. Which, as you know, 6 inches is half a foot, 0.5 of a foot, with concrete. We want to know how many cubic yards of concrete are needed. So total volume, we have the 4 times the 200 times the 0.5 to get the volume of the concrete, length times width times height. So we're going to take that volume that we know, the 400 cubic feet, and again, we've got to convert 1 yard to 3 feet into cubic feet, so they cancel. So this time we're going to cube that whole fraction. 1 cubed is 1, so we get 1 cubic yard up top, and then 3 cubed is 27, 3 times 3 times 3, to get 27 feet cubed on the bottom. So now if we do 400 divided by 27, we see that we need 14.81 cubic yards of concrete. Couple more definitions. Density tells us how crowded or compact a substance is, and there's 3 different types of density. Material density tells us mass per unit volume. Again, that per means divide. So we have the mass, which is the weight up top, and the volume, or the amount of space, is on the bottom. And just a fun fact, water is 1 gram per cubic centimeter. So if you envisioned a box of water that's 1 centimeter by 1 centimeter by 1 centimeter, that's what a cubic centimeter is. That's how much water weighs. And you can see if something's going to float or sink in water by comparing its mass. If you have something that weighs more than 1 gram per cubic centimeter, it's going to sink. But if you have something that weighs less than 1 gram per cubic centimeter, it's going to float. So that's how you know if something's going to sink or float in water. Also, we can have population density, which tells us the number of people per unit area. So there are 8,175,133 people in the 468.9 square miles that make up New York City. Well, if you take that 8,175,133, and if you divide it, because remember, it's people per unit area, that means divide, so our number of people divided by our area. So we put that 8 million number on top, and then divide it by 468.9, you see that there are 17,435 people per square mile in New York City. It's a lot of people. Imagine a box that's 1 mile by 1 mile. You're going to put over 17,000 people in that box. And then the last type of density is information density, and this just tells you how much you can store digitally. So an example of information density is my flash drive that I keep everything on will hold 4 gigabytes of data. So that tells us, oh, sorry, just knocked over something. That tells us how much data you can fit on a flash drive. And then our last definition for this section is concentration, and that just tells you how much of one substance you have mixed with another. Skittles are fun, one of my favorite sweet snacks, and I think the red ones are the best. So if I want to know what the concentration of red Skittles are, let's say I opened up a bag. If there are 10 red Skittles in the bag and 55 total Skittles, 10 divided by 55 is 0.18. That tells us that 18% of the bag is red Skittles. So that's pretty good for me. I really like red Skittles. One more example to finish up this video. Let's say we want to calculate how many people per square foot there are in New York City. Well, we're going to round our numbers a little bit to make it easy. Let's say that we have 17,435 people in every square mile of New York. It's basically the number we came up with a little bit earlier. Then we're trying to get per square foot, we're in square miles, so we've got to take our conversion fact that 1 mile is 5,280 feet. We've got to square both of them so that they'll cancel. And that gets us into square feet. And then when we do that division, we see that there's 0.0006 people per square foot. So that's basically telling us that every person gets more than 1 foot of space, which is good. You wouldn't want to have one person only able to occupy 1 foot of space. That's not even enough room to lay down.